Finding a linear model for your data. First, you can see we've already got our model plotted on a curve. I went ahead and used Excel to plot a trend line with the corresponding equation. And in order to come up with our linear model, we need both a slope and a y-intercept, right? Y equals mx plus b. Should look familiar. Now, to come up with a slope, we can either steal this slope, which looks about right. You see that's the one that I've gone ahead and plugged in there. Or we can come up with our own slope. You see what we've done here. Taken y2 minus y1 divided by x2 minus x1. Okay, once you get that inputted, we can go ahead and drag that down so that we get the difference, or the rate of change, between consecutive points on here. Then we can average that to get another estimate for the slope. Either one will work. If we use this estimate of 0.001, notice the big difference is that one's positive, whereas this one and this one are negative. Okay, looking at our data, we can see that there's generally a negative slope to that line. Obviously, if we take away this trend line as well, we should still see that there's negative correlation there. So, to come up with the actual linear model, okay, again, we need our slope and our y-intercept. I'm going to do this for every one of our x values over here. So I want this value for the slope to equal the value of that above it. And I want that to be the same all the way down. You can see down here, we've got that this cell is equal to the one above it, and so on. I want to do the same thing with the y-intercept. So I'll copy and paste over here. And then my linear model, or the y value, is going to be y equals m times x plus b. Okay? M x plus b. Hit go. Whoops. It will bring that all the way down. Okay, so now I've got possible y values, or model y values, for each of my x values. We can check to make sure that they're roughly the same as their corresponding y values. 73.5, 73.5-ish, 73.8, or 74. Okay, they roughly correspond. So now I want to plot those on this chart to get an idea for whether or not those are a good model. I'm going to call this my linear model. The x values, we're going to use those original x values, and my y values now are going to be those of my model. Okay. Hit OK, hit the go button, and you can see those by those orange dots, we've got our linear model plotted. Now, of course, this is going to look fairly similar to that trend line because we used similar slope and y-intercept values. If I was to take this slope and plug it in here, you see we're going to have issues. Namely, now my y-intercept has to change. I need to bring this point way down here somewhere. So I'm going to move this point down, what, about 5 or 6 points. So I'll go ahead and make this 70 now. And we can use this process, bump it up again maybe, so 71, to try to get that line to better model our data. Okay. Of course, this doesn't look right at all. Our data seems to generally be moving in the downward direction. So I'll change this back, 0.001 and 76. Okay. Now we've got a pretty good estimate for our model, or for our linear model. We can see those y values there. If we were to actually type out the linear model, that would be y equals, what is it? Negative 0.001 times x plus 76.